Okay, so thus far we've talked about the basics of C Sharp, which was a refresher for some people and new information for others. And then we talked last time about using some C Sharp basics. There wasn't really anything, I don't believe, correct me if I'm wrong, in the Flappy Bird tutorial that required C Sharp knowledge you didn't already have. I don't think. It was all variable declaration, if statements, etc. Right, and the engine was doing the rest of the lifting for you. Something that might have been some new information was when he made made the variable public so that we could access it from the engine, and also when it was on trigger enter. I think it's when he was doing the collisions for the score. I believe the on collision enter thing. There was a private function, right? A private method, which is something we haven't really talked a lot about, but we will talk about going forward. So more or less, it was all information you should have. And the reason I like his tutorials, and he's got a Pong one, which I think we watched last semester. We might watch it again. I don't know. We'll see. But he and others like him, they are expecting you to come into it with the level of C# knowledge that you all have, and that any features or capabilities that you need, the engine can take care of. You know, the idea of doing something like, well, I'm going to make a game just by writing C# code, is something that you can do later on, right? You know, that it's more important you get the principles down right now. So what we're gonna start is watch today is a series of videos on how to make the Chrome runner, the dinosaur game, the Chrome runner, okay? So if you got on Canvas already, you should have the assets for that, should have Unity pulled up, and you should be able to follow along. One quick note on this series, I'm not sure what happened with his audio because this one came out back in November, and I don't know what happened in between the time he did the Flappy Bird one and did this one, but his audio is really weird, and he's a little hard to understand at times, but I don't think you can watch what he's doing and more or less follow along, I think. So without further ado, let's hop over here and check out this video. Yes.
My copy of Unity is still installing, but if it's just me, then
Oh, is there anyone else that needs me to pause for a few moments while we install? All right, no problem. Well, while we're doing that then, let's have us a quick discussion about, well, a few things. Unity, C#, that kind of stuff. What is everybody thinking they might want to do for their, I got to turn the light off and shut the door. Could you turn the light off for me, please? It's the one closest to the door. As soon as I sat down, I was like, it seems brighter in here than I expected it to be. Okay, so what is everyone thinking that they're going to do for their project? Just like with 120, I need to be able to tell from your project that you spent one semester at least in C#. Okay, so which is to say, you could do something in Unity, but I don't want you to just open up one of the prefab like demo games, change a thing or two and say done. You know, like I would need you to make need to make significant changes to the game in some way through C# code, not just through the engine. You could do a simple text-based recipe program or something. Text-based, totally fine if you want to go that route, but it needs to be a little meatier than what you did in 120, okay? So just like a thing that's like, oh, like guess a number between 1 and 10, like no, that's nowhere near complicated enough, right? We're gonna need to see some classes and objects show up. I'm gonna need to see a decent amount of custom methods. Some arrays should make an appearance probably, things like that. So anything that you can think of that would incorporate the building blocks of programming as they are applicable to C#, so arrays in C# and things like that, and demonstrates an understanding of how C# code is written, you should be good. So does anybody have any ideas of what they might want to do? Any questions as to whether it might meet the requirements? Any other questions of any kind? Does anybody have any idea at all what they're doing? Yeah, what's up?
probably just a 2D ARPG in Unity, like with a level or two.
Okay, cool. Yeah, I like that. I like that. We've got some videos that we will watch moving forward. You No, I guess that was a different class. I was thinking that I showed those in 220 last semester, but I didn't. Um, there's several videos that we're going to watch by a YouTube channel called Brackies, which you did see some of last semester, I think. But going over those sorts of things, like how to do just like a sort of a 2D platformer kind of thing, how to do enemy like tracking, like so if you get near them, they'll chase you around the screen or whatever, and different things like that. We'll learn how to do maybe some dialogue boxes, some turn-based battles, maybe if the different things like that. We're not going to take a deep dive into any of those topics, right? So I'm not going to show you from start to finish how to make a platformer. I will. So like, excuse me, hold on just a second. Ah, okay. Sorry, I get a barrage of emails there for a second. So anyway, um, I will show you some like Unity only video, for example, like I guess arrays are involved, but like how to add sound to your game, for example. Um, I will show you some videos on that just because I know that for those of you that are doing, say, like a 2D action RPG, you probably want some sound effects or some music playing or something. So I'll show you a few of those things, but pretty much every video we watch going forward is going to be pretty heavy on the code side of things. It's basically using Unity to like render your graphics and your collisions. That's basically like which if you've done game development in the past is one of the biggest hurdles that game developers have to overcome is writing a game purely in code is not that difficult. Detecting collisions and determining terrain and things like that purely in code is very difficult. And so that's where Unity kind of excels, is picking up some of the slack in that regard, that it says build a tile map, just kind of put your level together like Legos, and we'll worry about the physics of it all and that kind of thing. So cool. All right, anything else? Any thoughts as to what you might want to do? No? Any questions? Okay. Everybody ready to go? We still need a little more time?
Yeah, I got a question.
Yes, sir.
So, I'm installing it because there's not a version on here, and it's I selected the recent version of Unity, and it's telling me to. Well, it's recommending I install the Microsoft Visual Studio Community 2019 module, which seems unnecessary.
It is. Yeah, you don't need to do that. You already have Visual Studio installed. You have Visual
I didn't
Studio.
know if it was a different thing or if it was actually going to try to install Visual Studio.
It would if you left that checked, yes,
Okay.
because the version of Visual Studio you have is 2019 Professional,
Right.
and yeah, so yeah, you don't want to do that. So all right, if everybody is good to go, you want me to wait on you, or are you good to go?
I'll just watch.
Are you sure?
Yeah, I'm also no. I got all
Okay.
weekend and
Okay.
so I can catch up.
Okay. And you can probably get caught up during the break too, or if you want to, or whatever. It's not a big deal. Okay, so let's switch over then, and let's check out this first video in this series.
Hello guys, and welcome to another course of Broskis Games. In this course you will learn how to do the dinosaur game of Google Chrome. If we press the play button, you can see that the dinosaur starts running. We can jump in the game, we can also crouch. The ground starts moving to the left, so that's really nice, and the clouds too. And the current score is increasing as the time passes by, and we have a high score too. And instead we lose, in the moment we lose, we have a game over state, and we have a replay button so that we can start again. And yes, it's really similar to the original one, so it's quite nice. When you finish this course, you will be able to make this game too. So yes, let's get started. By the way, I have made my own version of the game, but with a little twist. You have the day and the night mode. You can choose between different characters, different dinosaurs. Each dinosaur has a color. And there's also meteorites that come from the sky. It's really fun, it's a bit difficult, but it's also entertaining. So yes, feel free to download it. You have it available in the Google Play Store. So the first thing you have to do is open Unity Hub. If you don't have Unity Hub installed, you can click in the top right corner. You will have a link to our quick tutorial that you can follow to have a good setup of Unity. So let's create a new project. Let's call it Chrome Dinosaur. And let's save it here in desktop Unity games, and this game will be a 2D game, so let's click here in 2D game and let's click create. Okay, perfect. So the editor is opened now. We have the new project Chrome Dinosaur, and the first thing I like to do in the project is save as the scene so that we can rename it. Let's save in the scene folder, and let's save it with the name game. And then let's go to the folder scene here in the project view, and let's delete the sample scene. Okay, so now we make sure we are working with the game scene. Okay, so the first thing you have to do is go to the assets, and let's create a new folder, and let's call it sprites. You will have all the assets you need down in the description, so make sure you download it. Here in the sprites folder that we just created, we are going to drag the sprites PNG image, this one right here, and let's set the configuration for this image. Let's say it's a multiple sprite. Let's change 100 pixels per unit to 24 pixels per unit. Here in the filter mode, let's put point no filter, and here in the compression, let's say none. This configuration is because it's a pixel art sprite, so let's apply. Let's open the sprite editor and let's slice everything. And we need to make some changes here. Let's first adjust the replay button. Then let's change some of the cactus sprites. For example, here is not 2 sprites, it's only 1. So let's delete one of the squares and let's expand the other one. And let's do the same here. Let's delete this square and let's expand this one. And the last change we need to make is the ground down here. We need to divide it into 2. So to do that, we are going to change the width of this square to 600 to the half. And let's drag another square here. Let's set the height, that is 15, the same height as this one. Let's drag the square here next to the other one. And let's put 600 of width. So now we have the ground divided into 2. You will know why we did this as we move on in the course. Okay, let's click apply and let's close the sprite editor. Okay, so now we have all the sprites in the sprites folder. You can see all of them here. And let's change the main camera background to F7, F7, F7. This is the background that has the original game. And yes, now we can drag, for example, the ground here. And we can drag also the dinosaur. And we can drag the cactus. We can drag all the sprites in the game scene. So yes, this is for episode 1. We have now the sprites. We can drag it to the scene. In the next episode, we will work with the dinosaur. We will make the dinosaur collide with the ground, and we will add physics to the dinosaur, such as gravity. So see you in the next episode.
Real quick, something that you might consider perhaps doing is kind of imitating what he does in his custom version, but instead of multiple dinosaurs, maybe you could have Ozzy or a character of your own creation that is maybe you could use the concepts we learned in the Flappy Bird video to make it where you're, instead of flying over or in between pipes, you're flying over top of trees and underneath other birds or something like that, right? So just make sure that you're keeping your mind open to different possibilities of projects that you could potentially work on.
What does the F7 do? Because whenever I press it, it doesn't do anything.
When did he do that? I must have not caught that.
I think that was the color code. You said like F7, F7, F7.
Yeah. Okay.
Okay.
Yeah. Okay. Sorry, I was like, I didn't recall him doing that as a hotkey. Yeah. It's a hex code for the color that he was using.
Okay, so welcome to episode 2 of this course. In this episode, you will learn how to make the dinosaur and the ground collide, how to add gravity to the dinosaur, and how to make the dinosaur jump and crouch. By the way, I have made my own version of the game, but with a little twist. You have the day and the night mode. You can choose between different characters, different dinosaurs. Each dinosaur has a color, and there's also meteorites that come from the sky. It's really fun, it's a bit difficult, but it's also entertaining. So yes, feel free to download it. You have it available in the Google Play Store. So the first thing we have to do is change the name to the dinosaur. So let's change it right here in the top. And let's change also the name to the ground. And let's delete the rest of the sprites that we have in the scene. We don't need them for this episode. Okay, so let's start adding gravity to the dinosaur. Let's put the dinosaur here, for example, and let's add a new component to the dinosaur called rigid body 2D. Okay, so now if we press the play button, we will see that the dinosaur will fall. This is because the gravity scale is set to 1 by default. If we put, for example, 5, the dinosaur will fall quicker. Okay, let's change it back to 1. And we can see that the dinosaur and the ground are not colliding. To make them collide, let's add a new component to the dinosaur called box collider 2D. If we get closer to the dinosaur, we can see that it has a green box around it. This is the box collider. We can change the size here in the component, in the x-axis and in the y-axis. Let's put it like this, for example. And let's add a box collider to the ground too. So now both objects have a box collider. Let's press the play button. And now we can see that both objects collide. To make it more realistic, let's, for example, change the box collider of the ground. And let's move it in the y-axis a bit down. So that now if we press the play button, it's a bit more realistic. Okay, perfect. So now both objects are colliding and the dinosaur has a gravity attached to it. Let's put the dinosaur a bit down. Okay, so now to make the dinosaur jump and crouch, we need to create a new script. To do that, let's go to the assets folder and let's create a new folder called scripts. Inside this new folder, let's create a new script. And let's call it dinosaur. Okay, let's open it. Okay, so here in this script, we can set the behavior of jumping and crouching. The first thing we have to do is declare a variable of type rigid body 2D. And let's call it RB. And here in the start method, let's say RB is equal to get component. So this get component is going to get the component rigid body 2D of the dinosaur. So it's going to get this component. In the dinosaur, if we click in the dinosaur, it's going to get this component rigid body 2D. So now this component rigid body 2D is going to be equal to the variable RB. And here in the update method, we put the following code. So this means that every time we press the spacebar, the dinosaur is going to move in a velocity of 5 in the y-axis. Okay, so that's basically it. It's really simple. So let's try it. But first we have to drag the dinosaur script to the dinosaur object. Okay, don't forget to do this because otherwise it won't work. So let's drag the script file to the dinosaur object. Now we have the script file here. Make sure it's here. And now if we press the play button, if we press the spacebar, the dinosaur is jumping. But it's not really similar to the original game. So in the original game, the dinosaur jumps faster and falls to the ground faster. So let's change a bit the power of the jump. Let's set it to 20. But now if we press the play button, the dinosaur is going to jump really far. So we don't want this. We want the dinosaur to fall quicker. So to do this, let's go to the rigid body 2D components of the dinosaur. And let's change the gravity scale. Let's change the gravity scale to 6, for example. Now it's pretty similar to the original game, but there's a problem. If I hold the spacebar, the dinosaur keeps jumping, and we don't want this. We want only the dinosaur to jump one time, not as many times as we want. So to do this, let's change a bit the code. Okay, to do this, we are going to declare a new variable of type bool. Let's call it isJumping. And this variable, when the game starts, is going to be equal to false. Basically because the dinosaur isn't jumping at the beginning of the game. So if we press the space bar and the dinosaur is not jumping, then the dinosaur will jump, and is jumping obviously is equal to true. Okay, perfect. This way the dinosaur will only jump one time. But now we have to set is jumping to false again. To do this, we're going to create a new method called private void on collision enter 2D. It's important to put 2D, and here we will put is jumping is equal to false. This way, when the dinosaur collides the ground, is jumping is equal to false. This means that the dinosaur isn't jumping, so that we can jump again. Okay, let's save and let's try this. Let's press the play button, and now we can see that if we hold the spacebar, it's going to jump only one time. Okay, this is perfect. Now the dinosaur can jump. Let's make the dinosaur crouch. Okay, to do this, let's go to the sprites folder And let's drag a sprite of the dinosaur crouching. Let's call it dinosaur 2. Let's add a collider to it too, but it will be a different collider. Let's make it like this, for example. And let's put the dinosaur 2 in the same position, more or less, than the dinosaur 1. Okay, so to make the dinosaur crouch, we have to make invisible either dinosaur or dinosaur 2. It depends on what key we are pressing on the keyboard. So for example, if we are not pressing any key at all, then dinosaur 2 will be invisible, just like this. And if we are pressing the down key, then dinosaur will be invisible and dinosaur 2 will be visible. So we have to play with these things in the code. Okay, so to do this, let's go to the scripts folder and let's create a new script called dinosaur 2. And let's open it. So before starting with the dinosaur 2 script, let's add some code to the dinosaur script. And the first thing we have to do is add two new variables that will be public game object stand and public game object crouch. Okay, so in these two new variables, we will get the two game objects right here, dinosaur and dinosaur 2. We will get these two objects. Let's add the following code to the update method. Okay, so this means that if we press the down key and if the dinosaur is not jumping, that means that the dinosaur is colliding with the ground, then the crouch object will be set to true. That means that the crouch object will be visible and the stand object will be equal to false. This means that it will be invisible. So this way the dinosaur will be crouching. This is all we need to do in the dinosaur script. Let's save. And now let's go to the dinosaur 2 script. Here in the dinosaur 2 script, we have to declare the variables 2. And in the update method, let's add the next code. Notice that I have put getKeyUp instead of getKey. This means that when we stop holding the down key, then this will happen. That means that the dinosaur object will be visible and the dinosaur 2 object will be invisible. And remember, I have put public in these variables. This means that now in the editor, we have to drag here in the script component the objects to the script. Okay, so now let's drag the dinosaur object to the stand variable and let's drag the dinosaur 2 object to the crouch variable. And let's do the same with the dinosaur 2 object. The dinosaur 2 object needs the dinosaur 2 script, so let's drag it and let's drag the dinosaur object to the stand variable and let's drag the dinosaur 2 object to the crouch variable. Okay, we also need to make the dinosaur 2 invisible and the dinosaur visible because at the beginning of the game we are not pressing any keys. So now if I press the spacebar, the dinosaur will jump, and if I press the down key, the dinosaur will crouch, and if I stop pressing the down key, the dinosaur will stand up again. This is perfect. This is just like the original game. Okay, so this is all for episode 2. In the next episode we will learn how to make the ground and the clouds move to the left. See you in the next episode. Okay, so welcome to...
Hint, it's done in a very similar way to how we did the pipes in the previous game. In fact, it is almost identical.
Episode 2 of this course. In this episode you will learn how to make the dinosaur and the ground collide, how to add gravity to the dinosaur, and how to make the dinosaur jump and crouch. By the way, I have...
Hold on just a second. Sorry. I don't know why that did not go to the next video. It should have. My bad.
Okay, so welcome to episode 3. In this episode we will learn how to make the ground and the clouds move to the left. By the way, I have made my own version of the game, but with a little twist. You have the day and the night mode. You can choose between different characters, different dinosaurs. Each dinosaur has a color. And there's also meteorites that come from the sky. It's really fun, it's a bit difficult, but it's also entertaining. So yes, feel free to download it. You have it available in the Google Play Store. Okay, so let's go to the sprites folder. And let's add some clouds to the scene. And here. You can put it as you want, it doesn't really matter. Let's change the name. Let's put cloud 1, for example. Cloud 2. Cloud 3. And cloud 4. Okay, so now we have to make the ground and the clouds move to the left. Let's first center the ground in the x-axis. Let's put here 0. And let's add the other half of the ground. Remember, in the sprite editor we divided the ground into two parts. Let's put the other part here. Let's call it ground 2. And let's add a box collider too. Remember we put more down the boss collider. Let's do the same thing in the ground 2. Here, let's copy and paste. And let's put the same position in the y-axis. Let's copy and paste too. And let's try to put the ground 2 next to the ground 1, okay? Okay, so to put ground 2 next to ground 1, just put 25 in the x-axis of ground 2. So now both of them are next to each other. Okay, so let's make everything move to the left. To do this, let's go to the scripts folder and let's create a new script called move left. Okay, let's open it. And here let's declare a variable called public float speed. And here in the update method, let's put the next code. Okay, so this means that the object that has this script attached will move in the x-axis in a negative way, this means to the left, with the speed that has been declared in the editor, because it's public, okay? And will remain the same in the y-axis. So let's save, and let's go to the editor, and let's drag to the ground this script, and let's put a speed of 8, for example. You can see that the ground is moving to the left. Okay, let's put as well the script to the ground too. Let's put the speed to 8. And let's put the script to the clouds, and this time let's put the speed to 3, for example, or 2. Okay, so everything is working fine. It's really smooth. Now what we want to do is when an object arrives here to the left, we want the object to be repositioned to the right so that it's an endless loop. To do this, let's go to the code. Let's add 2 new variables called end and start. And let's add the next code to the update method. So this basically means that when the object that has this script attached arrives to the end position, then it will be repositioned to the start position. Both of these positions we will set them in the editor because both of these variables are public. Okay, so let's save and let's go to the editor. Now we can see, for example, in the ground object, we can see that in the script we have 2 new variables here. Okay, so now what we want is whenever the ground arrives to this position, we want to reposition the ground to this position so that it's always going through the scene. I have already tried this and the start position is 25 and the end position will be minus 25. Okay, let's do the same for ground 2. The start position will be 25 and the end position will be minus 25. This way, if we play the game, you can see that the grounds, if I select the 2 grounds, you will see it, you will watch it clearly. The grounds are being repositioned so that it's an endless loop. But you can see that there is a mini error, and is that if we zoom here, we can see that there is a tiny gap between them. Okay, so to do this, the only thing we have to change is here, instead of putting minus 25, we're going to put minus 24.95. It's a really mini error, but I don't know, just change it and it will all go fine. So let's play again. And now you can see that the ground is moving perfect and it's never ending. So this is perfect. You can see that the clouds are doing a weird thing here. This is because here in the clouds we have set this by default to 0. Let's change it to 10 and minus 10. I have already tried it, so it's going to work fine. Oh, sorry, I have to change it in every single cloud. Okay, let's try again the game.
I also want to mention he could have selected cloud number 1, held shift, selected cloud number 4, and then changed those values for start and stop. And it would have changed it for all 4 of them.
Okay, so this is perfect. It's looking really good. This is it for episode 3. Now we have the ground and the clouds moving to the left. In the next episode, we will be creating all the obstacles that we have in the game. See you in the next episode. For episode 3, now we have the ground and the clouds moving to the left. In the next episode, we will be creating all the obstacles that we have in the game. Okay, welcome to episode 4. In this episode, we will be creating all the obstacles that we have in the game. By the way, I have made my own version of the game, but with a little twist. You have the day and the night mode. You can choose between different characters, different dinosaurs. Each dinosaur has a color. And there's also meteorites that come from the sky. It's really fun, it's a bit difficult, but it's also entertaining. So yes, feel free to download it. You have it available in the Google Play Store. Let's create a new object here. Click create empty. And let's change the name to obstacles. Click here and click in the green diamond, for example, so that we can see the object. And let's drag it, for example, here. Okay, this object will generate all the obstacles in the game. So let's go to the sprites folder and let's drag, for example, a big cactus here. Okay, let's add a box collider to the cactus. Let's adjust a bit the box collider so that it's more realistic. Perfect. And let's check the is trigger option. This way we can notice when the dinosaur and the cactus collide in the code, but they don't actually collide in the game. Okay, perfect. Let's change the name of the object. Let's call it obstacle 1. And let's put it, for example, here. Okay. Before coding, let's go to the assets folder and let's create a new folder called prefabs. In this folder, let's drag the obstacle 1 object. Now we have made the obstacle object into a prefab. This means that if we delete the object, if we drag the prefab to the hierarchy window, the object will be created with all the properties that we have set before. So now let's go to the scripts folder and let's create a new script called obstacles. Let's open the script. And here let's declare the next variables. Okay, the max time will determine the frequency in which the objects will be generated in the game. The timer is just a timer. And the public game object obstacle 1 is a reference to the prefab that we have created before. Let's add the next code to the update method. Okay, so here we set the timer, so this is a normal timer, and if the timer is equal or greater to the max time, for example 1 second, we can say here that max time is equal to 1 second. Then every second we will generate an obstacle, because every time we generate an obstacle, timer is equal to 0. So every second we will generate an obstacle, as simple as that. Okay, to generate the obstacle, let's create the next method. So here we're generating a new game object that happens to be obstacle 1, that we have declared in this variable. Remember, the variable is public, so we have to go to the editor. And we have to select the obstacles object, we have to drag the obstacles script. And now we need to drag the obstacle 1 object here in this script. But instead of dragging this object, let's delete this. And let's go to the prefabs folder. Let's select obstacles and let's drag the prefab of the obstacle 1. This way, the obstacles game object will generate the prefab obstacle 1 each second. One thing we can do is select the prefab obstacle 1 and drag the script's move left. Let's put the same speed as the ground, 8. And let's put the start to 12 and the end to -12. Let's press the play button. And we can see that nothing happens. Okay, let's go to the code. Okay, we forgot to put generate obstacles here. We have to call the method so that this happens, okay? So let's save and let's try again. Okay, now we can see that the cactus are appearing. This is perfect. But now we have a problem, and it's that we are generating numerous obstacles and they are reappearing here because of the move left script, okay? So if we go to the obstacle 1 prefab, we can see that in the move left script we have put here 12 and -12. So the cactus that are here are repositioning themselves here. And we don't want that. We want the obstacles to be destroyed when they arrive here, because new obstacles are being generated. So to do this, let's select the prefab. And let's tag this prefab. Let's click here and add tag. Let's click here in the plus icon and let's create the tag, for example, obstacle. Let's save and let's click again in the prefab, and now we can tag this prefab as an obstacle. Okay, let's save, and once we tag the prefab, let's go to the code and let's go to the move left script. Here in the script, inside this if statement, where we reposition all the objects, we're gonna type another if statement. So now with this if else statement, if the object that has this script attached has the obstacle tag, it will be destroyed. If it doesn't, then it will be repositioned. Let's save and let's try it. Okay, now the cactus are coming towards us, and when they arrive to the left, they are destroying themselves. This is perfect because new obstacles will be generated. Okay, let's create the other obstacles. To do that, let's go to the sprites folder and let's drag the other obstacles. For example, this one. Before changing the properties of this new obstacle, let's go to the prefabs folder and let's check the properties that the obstacle 1 has. Let's change the position of the prefab to 12 here and to minus 1.2. And let's try to put the same properties to all the obstacles. Let's click here and let's follow the following steps for all the obstacles. First, we have to change the name. Then we have to tag the obstacle. Then we have to set the position. Then we have to add the boss collider. Make sure you check each trigger. And the last step is to add the move left script. And when you have all the properties, just drag the object to the prefabs folder and delete it. We have to follow these steps for all the obstacles, but there's a difference. If we go to the sprites folder and we drag, for example, this obstacle, we can see that if we put the same Y position as this object, for example, minus 1.2, we can see that it's not really well placed. So this, for example, will be a bit lower. For example, to minus 1.5, okay? And for example, if we drag this obstacle, the right Y position will be 0, for example, for the bird. So that's the only difference, but for the rest is the same. So let's delete these 3 objects. Okay, so now I have the prefabs of all the obstacles. To generate all of them, let's go to the code. And here in the obstacle script, we have to declare a new variable for every obstacle. Okay, there we have, and we also have to declare a new variable called int choose obstacle that will choose randomly the obstacle that will be generated.
Now, before he goes any further, so lines 10 through 16, he's declared public game objects. Game object is a, by the way, is a custom data type within Unity. I figured you all assumed that, but I just thought I would tell you straight up that that was the case. So 10 through 16 declares 7 public game object variables, right? Line 18, what does it do? Right here.
Does it allow you to pick one of the game objects in the lines 10 through 16 by like a specific number?
Yeah, yes. But what is the big difference between these 7 and this one right here? One big major enormous, I mean there's several differences, but there's one big glaring difference, at least in my opinion. Can you see it well enough? Okay. Do you have any idea what it is?
Well, I know that that's an integer variable.
It is. There's one other big thing that those other ones have that it doesn't.
A name?
No. It's a keyword.
Public?
Yeah, very good. Public. Any thoughts as to why it doesn't have that?
Doesn't Visual Studio, if you don't like declare it public, doesn't it like automatically make it private?
Yes. And more specifically, okay, so let me come at this direction. What is the purpose of making, in Unity at least, of making a variable public?
So you can like use that in the editor, like
Correct. Absolutely. So what would that suggest to you then, that it does not use that public keyword?
That you don't want to change the variable inside the editor,
Yeah, you want to change it where?
inside the script.
There you go. Excellent. So that kind of sort of underscores what I've said about making things public, private, and that sort of thing. In the context of doing it in Unity, you make it public if you want to specify, at least initially, or like an initial value or something from within the editor. Now that's going to come into play. That specific thing is going to come into play in the final video we'll watch after we finish the game itself. I've got one final semi-related video I want to show you. That If you want the code to determine variables values from the beginning, then you don't make them public. You just set them that way and then just refer to them in the script. So I wanted to go over that real quick before we move on.
To make this happen, let's add the next code to the generate obstacle method. Okay, so this way choose obstacle will have a random value between 1 and 7. You always have to put one more here. And depending on what number comes out, it will generate one obstacle or other. Let's save and let's try it. Before playing the game, if we select the obstacles object, we can see that we don't have an object for these variables. So let's drag the prefabs to those variables. Okay, so this is working great. This is it for episode 4. Now the game is generating all the obstacles that we have in the game. In the next episode we will make a game over state. See you. Okay. Okay, so welcome to episode 5. In this episode we will make the game over state, but before doing it I want to make some changes. By the way, I have made my own version of the game, but with a little twist. You have the day and the night mode. You can choose between different characters, different dinosaurs. Each dinosaur has a color, and there's also meteorites that come from the sky. It's really fun, it's a bit difficult, but it's also entertaining. So yes, feel free to download it. You have it available in the Google Play Store. First of all, let's make the ground a little bit lower. So let's set this to -2.5. Let's make this change also to ground 2. And let's make the dinosaur and all the obstacles a little bit smaller. So let's go to the dinosaur object and let's change the position to -7 to -2. And let's change the scale to 0.8 in every axis. Okay, so that way we made the dinosaur a bit smaller. Now let's make the obstacles a bit smaller too. So for the first 3 obstacles, let's put the next position, 12 minus 1.9. And in the scale, let's put 0.8 in every axis, just like the dinosaur. Let's do the same in the next 2 obstacles. And from the obstacle 4 to the obstacle 6, let's change the position in the y-axis to -2.1. Here in the scale, let's put the same, 0.8 in every axis. And let's do the same in the obstacle 5 and obstacle 6. And here in the last obstacle, the bird obstacle, let's put the y position to -1.1. And let's scale it the same as the other obstacles. And that's it. Okay, let's try this. Okay, perfect. Now it looks nicer. Oh wait, we have to change also dinosaur 2. Let's put here -6.8. In the y-axis -2.3. And in the scale, the same, 0.8 in every axis. Okay, let's try again. Has to work fine. Okay, perfect. Okay, so now what we want to do is whenever the dinosaur collides with an obstacle, we want to stop the game. So now if we collide with an obstacle, nothing happens. So we want to stop the game. We can see that the dinosaur is going behind the obstacles. To change this, go to the dinosaur object and change ordering layer to 1. Okay? Do the same thing to dinosaur 2. And this way is going to go to the front. And now the obstacles are behind the dinosaur. Okay, let's create a new object. And let's call it Game Manager. And let's create a new script in the scripts folder. And let's call it also Game Manager. Let's drag the script to the Game Manager object and let's open it. We don't need the update method for this script, so let's delete it. And here in the start method, let's put the next code. I will explain this to you in a second, but first let's create the next method. Okay, so when timescale is equal to 1, this means that the game will start at normal speed. But as soon as we call this method, then the game will stop. If we put here 2, then this means that the game goes faster. It would go at double speed. But we want the game to stop, so we are going to put a 0. Let's save this script. And we want to add some code to the dinosaur script. So let's go. And first of all, let's declare the next variable. So this variable is going to be a reference to this script, so that we can access the method gameOver. Okay, so once we declare this variable, we have to create the next method. Okay, first of all, make sure you put on trigger enter 2D, because if you don't put 2D, it's not going to work. And what this means is that if the dinosaur collides with an object that has the obstacle tag, then we are going to call to the gameOver method of the game manager script. Okay, so as soon as the dinosaur collides with an object with the obstacle tag, then the game will stop. Let's copy and paste this method to the dinosaur2 script. And let's also declare the variable game manager. Okay, perfect. Let's save all the scripts and let's try it. Before playing the game, we have to select the dinosaur object. And in the dinosaur script, we have to drag the game manager object here. And let's do the same in dinosaur 2. Okay, now we can try it. Let's click play. And now if we collide with an obstacle, the game stops. Perfect. Now we want a game over text and a replay button to show up. To do this, let's go to the hierarchy window and right click and create a UI text. You can see that the UI objects are created inside the canvas. Let's go ahead and change the settings of the canvas. And here let's select a screen space camera. And we have to drag the camera to the render camera. So let's drag the main camera to the render camera. And now let's change the UI scale mode to scale with the screen size. And we have to change the reference resolutions to the ones we have. That is 1600 and 900. Okay, perfect. Now we can edit our text. Let's select the text and change the name to Game Over. Let's change the text to Game Over, all in capital letters. And let's make it bigger, let's say 100. We have to make bigger the object so that the letter fits. So let's select the scale tool and let's make it bigger. Let's center the text. Okay, so now we want to change the font of the text. To do that, let's go to the assets folder and let's create a new folder called fonts. Let's open the folder. And in the assets you have down in the description, you also have this font. So just drag it. And now you have to select again the text object and drag the font here. Okay, perfect. Let's make it a bit bigger. 150 is okay. And let's add some space between the letters. Okay, this looks nice. Let's put it here. Okay, and now we need the replay button. Let's right click in the canvas and let's create a UI button. Let's change the name to replay. And let's drag the replay sprite here in the source image. Let's change the width and the height to 100. And let's move it a bit down. Okay, this is perfect. Now let's create an empty object in the canvas. And let's name it Game Over Panel. And let's drag the Game Over text and the replay button inside this empty object. This way we can make invisible the Game Over panel when we start the game. And we can make it visible as soon as the dinosaur collides with an obstacle. To do this, let's go to the code. In the game manager script, let's add a new variable. Okay, so this variable is going to have the game over panel, and in the game over method, we are going to make this panel invisible. Okay, just like that. So let's try it. The game over panel has to be invisible when we start the game. So let's try it. Let's press play. Okay, so there's an error. That's because we need to drag the game over panel in the game manager. So let's drag the game over panel and let's try it again. Okay, perfect. Now let's make the replay button work. To do it is really simple. Let's go to the code. Here in the game manager script, we have to add a new library. Okay, so this library, scene management, will let us work with the scenes. Okay, so now we are going to create a new method. Okay, so in this method, we are going to load the scene game every time we click in the replay button. Let's save and go to the editor. And we can see that in the scene folder, we have only one scene, that is this one, and it's called game. Okay, so before playing the game, we have to select the replay object. And we have to go to the button component and add a new method here on the click event. We have to drag the game manager inside the object here, because it is the game manager script that has the restart game method. Let's click here in the function. Let's go to game manager and let's click in restart game method. So now whenever we click the replay button, the restart game method will be called. Okay, let's try it. And if we lose and we click the replay button, the game will start again. Okay, this is perfect. This is looking really nice. Now we have a game over statement. If we click the replay button, the game starts again. Okay, so this is looking really good. This is it for episode 5. Now we have a game over statement and we have made all the objects smaller and it looks nicer. So in the next episode we will create the current score and the high score just like in the original game.
Okay, so I'm gonna do that. We have to animate everything, and then we
Okay,
will
so welcome to episode number
be able
6.
to add some sound, which is the final thing that I'll show you. And then we will have ourselves the ability to make a fully functional game.
Okay, so welcome to episode number 6. In this episode we will create a score and a high score. By the way, I have made my own version of the game, but with a little twist. You have the day and the night mode. You can choose between different characters, different dinosaurs. Each dinosaur has a color. And there's also meteorites that come from the sky. It's really fun, it's a bit difficult, but it's also entertaining. So yes, feel free to download it. You have it available in the Google Play Store. To start with, let's create inside the canvas a new text object and let's call it score. Okay, let's change the text to 5 zeros and let's make it bigger. Let's put, for example, 60. Let's make bigger the object too, so that the letters fit. And let's change the font. Remember the font we had before? Let's drag the font in the font attribute. Okay, let's align the text to the left and let's move it to the top right corner. Okay, the text is still small, so let's make it a bit bigger. Let's put 90, let's put 100 for example. Okay, perfect. Now we have the score in the top right corner. Let's go to the scripts folder and let's create a new script called score. And let's open it. Okay, before we start to code in this script, let's add the following library. And now let's declare the next variables. Okay, so this variable score is the one we are going to be increasing here in this script as we move on in the game. This text variable will be a reference to the text component of the object. This variable is a timer, and this variable will say with what frequency we're going to be increasing the score. So let's put the next code in the start method. Okay, so at the beginning of the game, the score will be 0. The score text, as we said before, is a reference of the component text of the object, and we will set max time to 0.1 seconds. This means that every 0.1 seconds, the score will increase in 1, okay? And now in the update method, let's put the following code. Okay, so at the beginning we set the timer. It's going to be a normal timer, and when the timer is greater or equal to the max time, that it's 0.1 second, then we increase the score in 1, and we give to the text components the value of the score. To do that, we have to put score to string. We have to change the score that it's an integer. We have to change it to a string, and we put these zeros in this parenthesis so that it increases in 1 without losing the zeros that are before the current score. You're gonna see it now in the editor, and we have to set the timer to 0 again. So let's save it and let's try it. Before playing the game, let's select the score object and let's drag the score script. Okay, let's click play. And now we can see that the score is increasing while we're playing. Perfect. And now we have to create a high score. To do it, just duplicate the score. Change the name to high score. Let's change the text to high and 5 zeros. And let's move it a bit to the left. Let's put another space in between the high and the zeros. And let's remove the score script component. Okay, so now when the dinosaur collides with an obstacle, if the score is greater than the high score, then we have to save the value of the score in the high score. Okay, let's go to the code and do that. First of all, let's declare a new variable. In this variable, we will save the text component of the high score object. Okay, let's add the next code to the start method. Okay, so I will explain this line of code to you later, but for now, let's add some code to the update method. Okay, so player prefs is a way to save data. So thanks to player prefs, we are going to save the value of the high score. When we say player prefs dot getInt high score, 0, we are basically trying to access to the data of high score, and if there isn't data available, then we are going to have a 0 in return. And when we say player prefs dot setInt, we are giving to the data high score the value score. So this code basically means whenever the game stops, if the score is greater than the high score data, then we're going to set into the high score data the value score. And we're going to change the text component of the high score object. And whenever the game starts, then the text component of the high score object will have the value of the high score data. I hope I have explained myself. Let's save and let's try it. Before playing the game, let's select the score object. Let's go to the score script component and let's drag the high score object to the high score text variable. Okay, let's click play. And now, whenever we lose, the high score will be updated with the current score if this one is greater than the previous high score. So yes, we can try again. We have 30 of high score. If we increase the number, then the high score will save again. Let's try to do more. Okay, now that we have 63, because 63 is greater than the previous high score, it will be updated. Let's try again and let's do less than the high score. See? If the score is less than the previous high score, then it won't be updated. And if we stop the game and we play the game again, the high score is still saved. Okay, this is working fine. This is it for episode 6. In the next and last episode, we will see the animations and the sound effects.
Okay, so let's chat for just a quick second before we watch that last video here. Did you understand his explanation of how he was doing the high score? No. Okay. So let's think back for a second. His is actually simpler than what we did in 120, right? We talked about how you could hold up to 10 high scores, right? Let's think simpler and let's step through how we would do it in a text-based version of C#, okay? But with just a single high score, okay? To simplify things. Okay, so the current high score is 1,000. Current high score is 1,000. Okay, I play the game and I get 500 points. Somebody raise your hand and step through the logic of how I would determine whether or not that score will become the new high score. Okay, original high score was 1,000. I just scored 500 points. Somebody step me through how I would. You can use pseudocode. You don't have to tell me exactly what it would look like, but just give me a logical idea of what it would be. Any thoughts? Yes, sir.
Maybe something like if current game score greater than I score, then replace I score.
Yeah, very good. It would just be if current score is greater than, not greater than or equal to, but greater than high score equals current score, right? That's effectively what he's doing. The only difference is, well, I guess there really is no difference, but the difference, if you will, is that we did ours at the conclusion of the game, like after we'd gone through the entire game. This is an endless runner, so as soon as he collides with an object and the game stops, if that number on the right there, which represents the current score, is larger than the current score. If it's larger than the high score on the left, then as soon as you reload the scene, it will update the high score with your new high score. Okay. The only reason it doesn't do it immediately when the game is over is because when the time scale is set to 0, everything freezes, and so it won't visually. So in the code, in the computer's brain, that change has already occurred. You just won't see it reflected visually until the scene is reloaded. Okay, and that has to do with the player preferences thing that he talked about, which allows us to save persistent data. Okay, which you could also use to player prefs is also used to be a save file and things like that, just a regular ordinary save file. So okay, let's real quick. I'll switch over and we'll watch the one on animations. Then we'll watch our sound video, which shouldn't take very long, and then come back and we'll have our lab time. So let's check out the animations, which if you kept up, if you've been working in Pace and have already concluded his Flappy Bird series, you already should be, well, I guess he did animations earlier in that one. So you should already be familiar with most of the things we're getting ready to talk about.
Okay, so welcome to the last episode of this course. In this episode, we will create animations and we will give sound effects to the game. By the way, I have made my own version of the game, but with a little twist. You have the day and the night mode. You can choose between different characters, different dinosaurs. Each dinosaur has a color. And there's also meteorites that come from the sky. It's really fun, it's a bit difficult, but it's also entertaining. So yes, feel free to download it. You have it available in the Google Play Store. Okay, let's start by animating the dinosaur. Let's select the dinosaur and let's go to the animation window. Perhaps you have the animation window right here next to the console, but I prefer to have it here next to the project window. Let's drag this a little bit and let's click create. Make sure you have the dinosaur object selected. Okay, let's go to the assets folder and let's create a new folder called animations. Okay, let's go inside the animations folder and let's save the animation with the name run. Okay, once we have the animation created, let's go to the project window and let's go to the sprites folder. Okay, let's go to the sprites where the dinosaur is walking and let's drag both of them, because we have two. Let's drag both of them inside the animation window. Okay, we need to drag another again the first sprite so that it's a loop. Okay, let's drag this down so that we can see the sprites. And now let's zoom in so that we can adjust the velocity of the animation. Okay, let's click play to have a preview. Okay, I think that's perfect. Okay, let's do the same with the dinosaur 2 object. Let's select it, let's create a new animation. Let's call it run2. And let's drag the sprites of the crouching dinosaur walking. And let's drag another again the first component. Let's zoom in and let's set it the same as the other one that was like this. Okay, let's make dinosaur 2 visible and let's make invisible dinosaur so that we can have a preview. Let's select dinosaur 2 and let's click play. Okay, it would be like that, it looks fine. So let's pause and let's return dinosaur 2 visible and dinosaur 2 to invisible. Okay, let's click play. Let's take a look. Okay, it's working fine. So the dinosaur is now running and you have the animation of the dinosaur. Now we have to create an animation for the bird, because the bird has an animation also. But yes, it's looking fine. Okay, let's go to the prefabs folder. Let's select the bird and let's drag it to the hierarchy window. Now that we have the object obstacle 7 selected, let's create a new animation. Let's go to the assets folder and let's go to the animations folder. And let's call it fly. Okay, let's go to the sprites folder and let's drag both of the flying bird sprites. Okay, let's play to have a preview. Let's make it a bit slower. Okay, I think like that is better. Okay, perfect. So now let's go to the prefabs folder and let's delete the prefab that we already have. And let's drag again obstacle 7 to the prefabs folder. So now we have updated this prefab. Okay, let's delete the obstacle 7 object. And let's go to the obstacles object. And remember, this object had this script attached. So we have to drag the obstacle 7 again to this script component. Okay, let's try it. Okay, as we can see, the dinosaur has the animation and the bird has the animation too. Perfect. Okay, let's add the sound effects to the game. To do this is really simple. Let's go to the dinosaur object and let's add a new component called audio source. Okay, in this component we have to uncheck the play on awake and let's go to the assets folder and create a new folder. Let's call it sounds. Let's go inside the sounds folder, and in the assets you have in the description you also have the sounds that we are going to use in this game. So download it and open the folder where you have them, select all of them and drag it to the new folder that we just created. Okay, so now select the dinosaur object again go to the audio source component and drag the jump sound to the audio clip. Okay, perfect. Now let's go to the code. Let's go to the dinosaur script and let's create a new variable. Okay, this variable will get the audio source component of the dinosaur object. To do that, let's type the code in the start method. Okay, perfect. Now the variable is equal to the audio source component. Let's go to the update method, and whenever we jump, we're going to play the sound. So jump sound dot play. Okay, perfect. Let's save it and let's try it. Okay, let's play the game. Okay, it sounds perfect. Okay, now we have to add the sound whenever we lose. To do that, let's go to the game manager object and let's add an audio source component. Let's uncheck play on awake and let's drag the lose sound to the audio clip. Okay, let's go to the code. Let's go to the game manager script and let's declare the variable audio source. Let's get the audio source component from the object and let's play the sound whenever we lose. Okay, as simple as that. Let's save and let's try it. Okay, perfect. Let's try it again. Perfect, it's working fine. Okay, so now there's only one sound left to add. So whenever we reach 100, 200, 300 points, we're going to play this sound. Okay, to do this, let's select the score object and let's add the audio source component. Let's uncheck play on awake and let's drag the sound to the audio clip. Okay, let's go to the code. Let's go to the score script and let's do the same. Let's declare the variable and let's get the audio source component from the object. Okay, and let's play the sound whenever we reach 100, 200, 300 points. So to do this, we have to go to the update method and inside this if statement, let's type in another if statement. And what this if statement says is that whenever the score divided by 100 gives 0 decimals, then we are going to play the sound. Okay, so for example, 200 divided into 100 gives 2, right?
Real quick, what is that called there on line 39?
Modulo,
Yes, very good, very good. And what does modulo do?
it divides and gives you the remainder.
Yes, it sure does. Excellent job.
Right? But it doesn't give 2.5 or 2.6. We're going to play the score sound whenever we reach 100, 200, 300 points and so on. Okay, let's save it and let's try it. Okay, so this is the game. This looks pretty much like the original one. It looks really smooth, it looks really nice, it looks really enjoyable. Let's do one more thing, and it's that whenever we reach 100 points or 200 or 300, that the game goes a little bit quicker, okay? Let's try to do that because it's really simple to do. To do it, let's go to the code. And the only thing we have to do is in the score scripts, here in this if statement, let's add another line of code. Okay, so this line of code, the only thing that does is increase in 0.1 the time scale. Okay, remember in the game manager we set the time scale to 1 when the game started. So therefore in the score script, every time we reach 100, 200, 300 points, we're going to increase 0.1 that time scale. So that for example, when we reach 100 points, it's going to be 1.1. When we reach 200 points, it's going to be 1.2 and so on. So let's save it and let's try it. Okay, 100 points, you can see that it went faster, but now in 200 points you will see that it goes faster. Okay, so let's try to survive as much time as possible. Wow, I'm really bad at this game, so but I'm sure you're going to do it better. Okay, so this is the game. I hope you enjoyed the course. I had a great time making this game, so I really hope you...
Okay, so the last thing I want to show you is very closely related to what he just did there with the sound, but it's a little bit more efficient of a sound manager. Okay, this is going to be your first introduction to okay, actually, yeah, let's do this. Okay, this video is about 15 minutes long. If you can hang on for another 15 minutes, I promise you'll enjoy this. Hang on for another 15 minutes, then we'll take a break and we'll come back and we'll start working on the lab. Okay. So
In this video,
here, actually, it's not quite 15 minutes because he usually has like a 5-minute commercial at the beginning.
In this video, we're going to have a look at adding audio to your game. The first part of the video will be an introduction to audio in Unity. We'll be setting up an audio listener and adjusting some audio source components to add sounds. And then in the second part of the video, I'll show you how to make an audio manager. The audio manager makes it really quick and easy to add new sounds and play them through script. I'll have a link where you can download it yourself, but in
One quick note, our friend the array is about to make an appearance. Okay? So it's why I made sure to go over arrays before we started doing any of this stuff.
In case you're interested, here's how it's done. So first let's go and create an empty game object. Let's reset the transform and let's call this one audio manager. Let's drag the game object to the top so we can always see it. Let's then hit add component and we want to add a component called audio manager. It's going to be of type C# and let's hit create an add. Let's double click it to open it up in Visual Studio. In the top here we can now delete the two using tags and instead write using Unity Engine .audio. Many of the new audio features in Unity are now wrapped inside of this namespace, so it's a good idea to include it whenever you're working with sound. Now the main idea for this audio manager is to have a list of sounds where we can easily add or remove sounds as we go, and each sound has some different properties. It has an audio clip, a volume and pitch setting, the possibility to loop, and you can add stuff like volume and pitch randomness or spatial blend. Then when we start the game, we go through the list, and for each item we add an audio source with the appropriate settings. Then when we want to play a sound, we simply call a play method on the audio manager where we input the name of the sound that we want to play, and the audio manager is then going to find the source with that name and play the sound. This makes everything so easy to use. So first we need a list of sounds, but we want to control what data is stored in each sound. And so let's go ahead and create a custom class called sound. To do that, we go inside of Unity, we go to the project and hit create C# script, and let's call this one sound. We then double click it, hit reload all, and in here we again want to be using Unity Engine.audio. We also don't want this to derive from mono behavior, and we want to delete the two methods. The first thing we want is a reference to our audio clip. So let's write public audio clip, and let's call it clip. We also want a volume. Let's write public float volume, and a pitch, public float pitch. Now we'll be adding some more to this as we go, but this is the base of our sound class. So if we save this, we can now go into the audio manager, and in here we create a public sound array, and let's call it sounds. Now when we save that and go into Unity and have a look under the audio manager, we would expect a list to appear. However, it does not. The reason why is that whenever we create a custom class and we want this class to appear in the inspector, we have to mark it as serializable. So right above the class, we make two square brackets and we write system.serializable. Now when we save and head into Unity, we can see that we have a list of sounds. Let's add an element, and the first element here has a clip, a volume, and a pitch. Now we can definitely make this more interesting. First off, let's go ahead and add a name. We'll make this a public string name, and we can also add sliders to our volume and pitch. To do that, we use the range attribute where we input a minimum and maximum value. We want our volume to go between 0 and 1, and we might want our pitch to go between 0.1 and 3. If we now save and go into Unity, we can see it looks much better. Let's name this first element player death, and I'm gonna drag in my player death sound. Now in our audio manager, whenever we start the game, we want to loop through our list, and for each sound, add an audio source. Let's do this inside of the awake method. Awake is pretty much the same as the start method, except it's called right before. So we set up everything in our awake method so that we can play sounds in the start. To loop through our sounds, we go for each sound, and we'll call the sound that we're currently looking at S. In our sounds array, we want to go ahead and add an audio source component. We could do that on our current object or on a child object. For the sake of simplicity, let's just do it on the current object. So we'll go GameObject.add component, and the component we want to add is the audio source. And of course we want to store this audio source in a variable so that later when we want to play the sound, we can call the play method on the audio source. The simplest way to do this is go into our sound class and add a public audio source and let's call it source. Of course, we don't want this to show up in the inspector because it's a value that we populate automatically in the awake method, and so we can mark this with an attribute called hide in inspector. So now even though the variable is public, it won't show. Let's save that, go into the audio manager, and now we can set s, meaning the sound that we're currently looking at, dot source equal to that new audio source component. And so we can set s.source.clip, meaning the clip of our audio source, equal to s.clip. And if we want to control our volume and pitch as well, we can set s.source.volume equal to s.volume and s.source.pitch equal to s.pitch. So if we save this now and head into Unity and hit play, we can see that at the start of our game, an audio source gets added for each sound in our sounds array, and that the clip, the volume, and the pitch all get copied over. So let's exit play mode and let's add a way to play this sound. To do that, we create a new method. Let's make this instead of the update method, and this one is going to be public, because we want to be able to call this method from outside the class. Let's call it play, and it's going to take in a string with the name of our sound. Then all we have to do is loop through all of our sounds and find the sound with the appropriate name. We could do that by creating another for each method and checking the name for each element, or we could go up here and say using system, and this now allows us to find a sound by going array.find. We want to find the sound in the sounds array, and we want to find the sound where sound.name is equal to the name. Now this type of syntax might be a bit new to you, but it allows us to write code a whole lot faster. We then store the sound that we found in a variable called s. And finally we can go s.source.play. Of course, this is going to throw an error if you don't find a sound with the appropriate name. We'll have a look at that in a second. So now our audio manager should actually work. We have a way of defining the sounds that we want. We set up audio sources for each sound when we play the game, and we have a method that we can call whenever we want to play a certain sound. So now we can find the place in our code where we want our player to die. Let's go into player, and here I have a script called player collision. Under this onCollisionEnter function, I check if what we hit was a meteor, and if it was, we want to go ahead and end the game and destroy the current game object. This is also where we want to play our sound. Of course, we need a reference to our audio manager. We could create a variable up here and reference it in the inspector, or since this is only going to be called a few times, we could use find object of type, and the type that we want to search for is audio manager. We then call dot play, and then the name of the sound that we want to play. In our case, that's player death. So now with a single line of code that we could put anywhere in any of our scripts, we can play a sound of our choosing. And so we should hear that when we hit play, and if I manage to collide with something, our player blows up. Now we can quickly expand on this to add some music. Let's add another element to our array. Let's call this one the theme. And I'm going to drag in my main theme here. Let's set the volume to something a bit lower and make sure the pitch is set to 1. And we can play this from anywhere, but let's just play it from within our audio manager. So let's add a void start method, and here we simply call play, and the sound that we want to play is theme. So now when we hit play, we can hear the music playing. Of course, we want our main theme to loop. To add this option, we go into our sound class and we add a public bool called loop. Then inside of our audio manager, where we set up our different sounds, we go s.source.loop equals s.loop. And now we have an option for looping. Let's go ahead and enable that. And when we now play, we can see that our main theme is set to loop. Let's see what happens if we make a typo. Say if we accidentally put a Q at the end of theme. This happens more often than you think. If we now hit play, it's going to try and play a sound that isn't there. So we get a null reference exception. To get around this, we simply check if s is equal to null, and if it is, we return. And so we don't try playing a sound that isn't there. Now when we hit play, even though the name is still spelled wrong, nothing happens. Now we can even go in here and add a tiny error message for ourselves. So now I'm just throwing out a warning saying that the sound with this name wasn't found. And now we pretty much can't break it. Let's change the name back here. Let's have a look at what happens if we add this to multiple scenes. The easiest way to do this is make a prefab out of the audio manager, then open up the other scene, in our case the menu, and drag the audio manager back in. The problem with this, however, is that if we hit play and transition to another scene, our music gets cut off. And we don't want our music to restart every time we change a scene. We want our sounds to be unaffected. To change this, we make the audio manager persist between scenes. Let's go into Visual Studio. Let's go to the top under our awake method. Let's add some lines. And all we need to do is call the don't destroy unload method. And as the target, we put our own game object. Now this also means that if we currently hit play and transition to a new scene, we actually have two audio managers in here. The one from the first scene and the one from the second. Now that's of course not something we want. So to get around this, we create a public static audio manager, and we'll call this instance. This is a static reference to the current instance of our audio manager that we have in our scene. And we want to make sure that there's only one instance. So we simply go in here and check if instance is equal to null, meaning that we don't have an audio manager in our scene. Well, then we set instance equal to this object. If not, meaning that we already have an instance in our scene, we want to remove this object. Destroy game object. And just to make sure that no more code is called before we destroy the object, we also hit return. Now, depending on whether or not you've worked with singleton patterns before, that might be a bit confusing to you, but just know that now when we hit play, our audio manager is set under the don't destroy and load scene. We hit play, and there's still only one audio manager. And you can hear that our music simply continues. So that's it for our audio manager.
Pretty cool, huh? The Flappy Bird clone that I in the class that I was teaching last semester made uses this exact principle so that when you're on the menu, you can go back and forth between different areas. You can start the game, get a game over, restart the game, and the music just plays on a loop. It doesn't restart every time and things like that. You can use either approach, either what the Chrome Runner guy did or what the Brackeys guy did. I recommend the Brackeys way just because, one, it allows you to use arrays, which is something you need to always be practicing so that you're really... It makes it so darn easy to do everything because it just copies everything over. Rather than having to type in numbers, you can just have that slider. You can have an option to loop or not and things like that, right? All right, cool. Any questions, concerns, comments, thoughts, ideas? Yes, sir.
Hey, what was the channel on that last video?
The one we just watched?
Yeah.
Brackeys.
Oh, okay, right.
Brackeys. Yeah, Brackeys. The other one is
Just Brackeys.
Brackeys. And the other one is Broski's
Yeah, I got it.
Games. Yep, cool. Awesome. Anything else? All right, come back at 10:30 and we will work on some lab time for a little bit.